Hey everyone, I'm Swati and welcome back to my series on mechanics. We are learning vectors and there were some issues in the last video. I don't know what happened, but suddenly the sound cracks. So today we going to continue from the thing which we left yesterday. So let's begin with that. Okay, so that was the last question which we were doing yesterday. So we'll continue from here only. So there was a condition in which a block is placed here at the origin of a Cartesian plane xy, and there were three forces acting on it: 10 Newton, then 4 Newton, and this F force. And they were asking what should be the value of this force F so that the object remain at equilibrium, which is placed at origin. Okay, so what we did basically, we take the components of this force. This 10 Newton has an angle of 30 degree here. So we make 10 cos 30 degree here. Whatever side has the angle takes cos as trigonometric ratio, the other goes with sine. And 4 Newton is a long axis, so we don't need to resolve it. And that F force can be written as xi cap plus yj cap. We are not taking sine here. We'll see what x and y comes out to be positive or negative. That would be the value of F. But as per the diagram, if your force F is acting here, then obviously this force, this 10 Newton force, should be balanced by some force here. So y should be negative. And again, this F is here, so its x component should be resolved here, so it should also be negative. But we'll see. Okay, so if net force is 0, then it means this 10 cos 30 degree. Let's take x components to be 0, then y components to be 0, then 10 cos 30 degree. And this 4 Newton, let's say this is I cap. This 4 Newton is along minus I cap, and let's take it plus I cap to be 0. Okay, we'll take x. See, you have to solve this x and y component separately. Okay, so the vector as a whole can be written in x and y components, but you have to solve x separately, y and z separately, and then you can combine the result and give you the net resultant. Okay, if it is not like to be in equilibrium, that is a net force on this is 0. There could be some force on that. Then also you have to calculate x component separately, y component separately, and then you have to combine them, and that would be the net force on this object. We'll do that also. So from here you can say that cos 30 degrees root 3 by 2, and we are taking all I components, so we can remove this I cap here. It's simply 4 plus x is equals to 0. Then it is 5 root 3 minus 4 plus x equals to 0. Either you can put the value of root 3 here, or x could be written as 4 minus 5 root 3, which is negative. Okay, I cap. And for the y components, you can take as 10 sine 30 degree and only this y, because for the 4 Newton there is no y component. So 10 sine 30 degree plus y equals to 0. Sine 30 is half, then it becomes 5 plus y equals to 0. Then y comes out to be minus 5 j cap. Okay. So that force should be equals to 4 minus 5 root 3 I cap minus 5 g cap. Okay. So it's something like this. Up now, if they ask that it is not in equilibrium, what is the net force? And this force also has some value. Let's take this, it's to be 12 Newton, and it makes an angle here. This angle to be, let's say, 45 degree. Then what you will do, you have to resolve that also. That is 12 cos 45 degree Here it becomes 12 sine 45 degree. And along x-axis, it would be what? Plus 10 cos 30 degree minus, because 4 Newton and this along negative x-axis, then it would be minus 4 minus 12 cos 45 degree. So that would be the result on x-axis. And for the y-axis, it's simply 10 sine 30 degree, because it is like positive y-axis minus this negative y-axis minus 12 sine 45 degree. And you will get the resultant along x-axis and along y-axis, and then you can combine it and get the net force on this object, which is Fxi gap plus Fyj gap. Okay, so if it is equilibrium, then if they say equilibrium or acceleration 0, or in uniform motion, or it's stable, then in all case your force is 0. Okay, acceleration also says that force is 0 because F is equals to m. If A is 0, then obviously F is 0 because mass cannot be 0. So yeah, so this is the thing which we have learned yesterday, which is a pre-cap, that you have to solve the x component separately and the y component separately, and then you can combine them for addition and subtraction. Okay, let's take one more example. Let's say your A vector is 4i cap minus 3j cap plus 5k cap. Okay, and B vector is something like I cap plus j cap. Okay, and if they ask the magnitude of the resultant, let's say magnitude of the resultant. Now you can add them component wise and then get the magnitude by taking the square of each component, or you can get the magnitude of individual and then. So you can simply get this resultant, which is 4i cap plus 1i cap, it is 5i cap, and minus 3j cap plus 1 is minus 2j cap, and it is plus 5k cap. And then you can get the magnitude, or if they ask unit vector, then you can get the unit vector of this R vector. So if they ask for magnitude, it's simply what? It is simply 5 square, 25, minus 2 square, that is plus 4, plus 25, which is 54. Excuse me. Something like that. Sorry. Okay. So that is simply the addition. There is no subtraction because you are considering the sign itself. If they ask that, find the magnitude of the resultant of A minus B. If they intentionally ask that, or if B is reversed and find, then you have to do that A minus B. Otherwise, if they ask for the resultant of this A and B vector, then it's simply like that. Okay, or if the direction changes, if B is in the opposite direction, then you have to use A minus B. Okay, so next is this direction cosines. Direction cosines are important. It's also a mathematical tool, but we can use this in 3D. In earlier lecture, I have told you that if your object is in 3D, if it is placed in 3D, let's say here is some object, and this is position vector A vector. What is position vector we will learn later. But let's say there is a vector A here. Now this A vector make an angle alpha with x-axis, but it also makes some angle beta with y-axis and gamma from z-axis. Now let's make this as R vector. Okay. Now if you take its component on x-axis, it would be what? R cos theta, right? Sorry, alpha. R cos alpha. Why? This is the base. This is hypotenuse. Then its x component can be written as R cos alpha. Okay. So from here, cos alpha would become x by R. Similarly, this cos beta can be written as y by R. So cos beta is equals to y by R. Okay, and this cos gamma if you take gamma here, then this R vector makes an angle of 90 degree with Z axis, then it would be Z by R with same analogy. Now these cos alpha, which is X by R, can also be written as L. This you will learn in maths. If you have maths, then you will surely learn that in grade 12, but it's just a notation. It's Y by R, that is equals to M, and cos gamma is equals to Z by R, which is N. And you can see that this L square plus M square plus N square is equals to 1. This is direction cosine. If they are direction cosine, then their square, the sum of the square is equals to 1. You can see from here that cos square alpha, cos square beta plus cos square gamma is equals to 1. How? Just make the square here. It is basically x square by r square plus y square by r square plus z square by r square. This is a little small proof. And if you see that is x square plus y square plus z square, it is nothing but it's z is r square. So this r square by r square, the magnitude is basically 1. So the direction cosine, the square of the direction, the sum of the square of the direction cosine is equals to 1. So this is a very important property. LM and R just the notation. The thing is you have to remember the concept. If you remember the concept, you can do anything. Any sort of numerical you can do easily if you remember the concepts. I believe that, rather than the tricks and the last formula. It is important to remember the last formula, but it is also very important, really very important to learn the concepts, because sometimes the numericals are not designed to check your memory thing, that how well you have learned the formula. It is more like how well you understand the concept. So you have to understand the concept, and it is a key thing. If you have to make your career in physics or in something like that code, then you have to remember the concept. It's important. Okay. So now let's take a vector A, which is 2i cap plus 3j cap plus 4k cap. Okay, and you have to find its direction cosine. Find its direction cosines. It's a very direct thing, but I'm doing this just for your understanding. So for the direction cosine, basically you have to find this cos alpha, which is x by r, and r is what? The magnitude of this A vector. So basically, first you have to find the magnitude of this A vector, which is what? 4, 2 to the 4, plus 6 is a 9, plus 4 for the 16. You have to square the coefficients of I cap, j cap, k cap, and you have to add it. Then it becomes 29. Okay, so now for the direction cosine, you have cos alpha, basically x component upon its magnitude, which is root 29, cos beta, which is 3 by root 29, and cos gamma, which is 4 by root 29. That's it. And if you square it, you will get 1. Next, so this is basically the thing, that how you can find the components and work with that. And basically this is the part 2 of yesterday's video, and I'm not starting anything new today. Tomorrow we will do some more questions and concepts on all the things which we have learned till now. We'll do more numericals and some high level questions, and then we'll move to the product rule, that is scalar rule and vector rule of this series, and which is most important. So yeah, today's lecture is also sort of on this. And thank you for watching this video, and do like and share for more such videos.